Hello everybody. Welcome to the first Wellcome Genome Campus Hackathon. We are very happy that you've chosen to take part in this project. Whether you've coded before or want to find out more, everyone is welcome. The Hackathon is part of the Cambridge Festival 2021 programme. For anyone who doesn't know, the Wellcome Genome Campus is a scientific research campus built in the grounds of Hingston Hall, Hingston in Cambridgeshire, England. The campus undertakes genome and biodata research and is home to two leading institutes, the Wellcome Sanger Institute and the EMBL EBI, as well as innovative genomics and biodata companies, scientific facilities, and a state-of-the-art conference centre. So before we start, I'd like to ask a few questions, which would be great if you could give answers to give us a bit more of an idea about our audience. So where are you joining us from today? And if you could put your answers in the Q&A chat. And we'd like to know about what your experience is of coding. So for 1, have never coded. 2, have coded a little. 3, have some experience. And 4, I'm an experienced coder. And please put your answers in the poll provided. And our final question, what do you think is the role of coding in science? An open question where you can put an answer in the Q&A chat, and we'll come back to those questions at the end. So a bit of a reminder for the workshop sign up. You will have been sent an email inviting you to sign up to the workshops throughout the week. If you've not done so yet, please see the appropriate links in the chat box and sign up ASAP. If you have signed up or will be signing up to the microbit workshop, you'll be sent a link to join the Zoom webinar and also to the Slido discussions. This means if you have any questions outside of the workshop, you can post them here and one of the coders will get back to you. If you've signed up or will be signing up for the COVID sequencing workshop on Wednesday or the Reefer workshop on Thursday, you will need to create a GitHub account. When you sign up to the workshop, you'll be asked what your GitHub username is, and you will then be added to the GitHub. On Thursday at 6 p.m, our guest speaker, Natalia, will be giving a talk about her journey in open source and how to get involved. It will be a 30-minute talk with a 30-minute Q&A and is open to anyone. So if you haven't already, please sign up. It will be a treat. I've heard Natalia speak many times and it's always been interesting. And if you have any more questions, please do email engage@wgc.org.uk if you have any issues with any of the above. So we'd like you to remind you that the event is live. So if something does go wrong, then please bear with us and we'll try and get it fixed as soon as possible. There is a Q&A box which you should find along the bottom or at the top of your screen. Feel free to post any questions you have in this box and we will either answer them live or reply through a typed message. You can hopefully also see a chat box. We will post any links or announcements here for you. The workshops throughout the week will also be in this format on Zoom. Please do ask questions during today and the workshops. Although it's been a year since we've had any in-person events, it's still very strange to be talking to a computer and only seeing ourselves on the screen instead of all your faces. So if you use the Q&A box and fill in the polls, then it lets us know there are people watching and taking part, which makes it a lot more fun for us. This event today and the workshops through the week will all be recorded. This is for safeguarding reasons, but also to be able to send to anyone who has signed up but cannot attend the workshop. So obviously we can't see your faces, but if you do want to ask a question and don't want your name read out loud, then you have the option to ask anonymously. We do have a code of conduct. Our events aim to help everyone to explore the science of genomics and what it means for all our lives. We respectfully ask everyone to participate in a spirit of curiosity and sharing, respecting different views, identities, and experiences. This platform is being moderated to ensure it is a safe and inclusive space for all. So without further ado, here is our first speaker, Rich Livit, and the title of the talk is Coding Is. It sounds very intriguing. Rich is my manager and has worked in software development for over 2 decades. And for the past year, he has been responsible for the smooth running of the project to track COVID samples on the campus, and he is lucky to manage a team of world-class developers. Over to you.
Thanks so much, Steve. That was a big welcome for me. Thank you. So hopefully you can all see my screen, and if anyone's got the voice, I can just check if that's okay. So coding in 5 minutes, I thought I'd start with. So we have this thought-provoking image by Dom Norman, and often we think about software design, we're thinking about building complex systems out of small components. So we often begin with something small. I have someone on voice. If someone can put themselves on mute, that'd be great. Thank you. Software out of small components, and we build them into systems of bigger things. And generally, we have to think about how those components interact together. So this particular item, the coffee pot, it's in some ways it's controversial design. It wouldn't be very useful to use, and we want our software to be useful. So most design basically resolves around the problem-solving exercise. So we think about the problem, we have to think creatively about some solution for that, and then we have to code that solution clearly without error. And that last part often seems to be the most difficult thing.
There we go.
And we code for two very different experts. The one we most people think of is the machine. We're coding on a PC or a Mac. The other one is the people. So for when you often first start in software development, you're coding for yourself in the future, making sure you can leave something understandable you can pick up again. And as you maybe pursue a career in software engineering, you'll start to code for the people in your team. And if your team can't follow what you've written, that causes problems. So most people see coding as some sort of black magic, but it can break down to 5 simple things. And in just about every other language we have input, which is graphical widgets, keyboards, or the network, and quite often that's the keyboard. The output, which is almost a mirror of the input, so it's things to the screen or things sent over the network. So often what we perceive with our eyes. Other examples could be, though, maybe touch. If you're an avid game player, the rumble of the gamepad is a haptic feedback, or potentially sound. Lots of software has noises to alert us to errors or something positive's happened. The other 3 elements of software, all found in all languages, is this idea of conditional branches, which is the software will take a different path and choose a different set of alternative instructions as it moves through its sequence of instructions. Next one is a repetition or a loop, very often seen, and that could also include the really particularly complex stuff about, I'll move on, actually I'll skip over that. And then last element, maths. So a little bit of maths.
Love some maths.
So we have these 5 items: input, output, which is something of the same, heads of the same coin, loops, conditional branches, and maths. And really, if you understand those things in your language, you can write some software. So software turns out to be quite a hard thing to do, and we have 3 common traps to think about. The first one is naming. So when we start programming, maybe it's a hangover from the past when machines were short on memory, we tend to name variables with these short 1-letter names because we're in a rush to get something working and finished. And really, it's very hard to understand what's going on there. Maybe with the word interest, you know, it's a bit about finance. It's much easier if you increase your naming conventions to be the words that name the concept. So it's much easier to follow what's going on here. Some payments being made to a customer. So be kind to yourself in the future when you're coding. Use long variable names and name things to bring forward the idea of what you're exploring, the model itself. So if it's a piece of labware, a plastic plate with wells in it, call it labware. The other thing that's a common error is that we need to set the value of a variable. So this variable here is box has location, and it's been set here to true. The second line looks very, very similar to the first, but we're doing something different here. We're asking a question. We're asking, does the box have a location? And if you've been coding for a number of years, you'll still make this mistake. You'll be lucky that most integrated development environments or IDEs will pick these things up, but not always. And it can be very hard to spot this in a big line of block of code you're working on for the day, and can be quite frustrating. And when you see it, it's a very painful thing to experience. The last one of these is I've just called it empty things. So maybe one of the almost equivalent of a hello world in Python here. We're asking the user for a bit of input, and the user will type maybe their name, and then we're going to reflect that variable back in the welcome plus their name. So we'd end up with something a bit like this. And that works fine. If we do it again, you could be in a situation where your user doesn't type in their name. And in the first example, it would still work. You just get welcome and a space. But we should try and have the habit of checking for things being empty. So in this case, we've got if no name, then we print no name provided. So it's a bit more elegant, our software. Where this is more often thought of is where you're handing in maybe a collection of something. So in Python, that would be a list. And if that list is empty, doesn't have an element or a thing inside the list, then it might perform in a way you don't expect it to do. So try and think when you're passing in things if they could be empty, and should I check for them being empty? So some tips. Often you get stuck with the code, and you've written a few lines of code, maybe a few methods, maybe even a fairly large chunk of software. And when you execute the program, it doesn't do what you expect. And that sometimes is a very common experience. One way to solve this problem is to sit down and carefully explain it to a friend. And it's often the case that as you start to explain what your code's supposed to do, you'll realize that it's not doing what you're supposed to do, and you'll see the error in your code. Now, that can be a bit embarrassing because often it's something, one of those mistakes about assignment versus checking for equality. So there's this concept called rubber ducking, and it's the same idea. You have a rubber duck on your desk, and you sit down and explain to the duck what you think your software is doing. And the duck's less judgmental often, and you don't feel quite so foolish talking to the duck, and you realize that, I see what the error I've made, and you can fix your error and progress. The other thing that's very true about software engineering is it requires a lot of concentration. You have to think about lots of different things. So if things are not working, take a break. And as Steve talked about, looking after teams of people, it's amazingly common how often people get stuck and they go to lunch and they talk a bit over lunch about the problem they've got, and then they'll sit back in their chair and think, and they realize what the mistake is. And sometimes you can beat that sort of lunch pickup by just taking a break and going for a stroll, go and look at something green, go and look out the window, go and do something different, take a break and get a drink. So coding is a huge subject. This is one of the slides or one of the tools we use at work to work out how we should invest in our training for one of the individuals in the team. And it's not so important the colors and the dots, but it is a big area. So we can think about, there's the things we're going to try and teach some of today if you're about coding and maybe a bit about version control. Steve mentioned Git right at the beginning of the talk. From that, also a bit about persistence, so the fancy word for storing data, most often in databases, but can be files to begin with. And there's also some exotic things that aren't SQL databases you can store your data in. There's, as you start building more and more enterprise type software, there's things to learn about automated test and continuous build environment. So your software is tested and built and deployed for you, the big systems. If you're starting to get into those sort of things, you tend to start getting interested in operating systems, so Linux and Windows there. And that almost always these days leads on to clouds, which is a fancy word for another person's computer. And lots of software now is deployed to the cloud. It's not all about technology. There's also people elements to it as well. So we spend a lot of time talking to our users to understand their requirements, and that takes a lot of skill. And it's the old name for it was business analysis. But these days, often we don't have a business analysis person in the team. We just, as a bunch of developers, understand the business problems and talk it through with the users. And that side is also very interesting. How do people interact with computers? That interface between you and the computer, how's it best used? How can people work efficiently? What do they find confusing about the interface? All under human-computer interaction. And keeping with the people side of it, running large, or supporting large groups of people building software. We have ways to do that with agile approaches and tools to facilitate getting people to work together and understand the problems. Unfortunately, as always with software, there's a bit of documentation, so leaving breadcrumbs for yourself and writing concise documentation is a real skill, and leaving it somewhere useful for people to find again. These days, increasingly as well, security, which is a massive subject in itself and increasingly important. And finally, there's the exotic stuff like artificial intelligence. So again, just to reinforce the point, there's loads to learn about software engineering. So there's a good chance you can make a career with it, and you'll always find something new to learn about. And it can be a bit daunting because of that. So where next? You've come to a hackathon, which I think is probably the absolutely one of the best ways to get started on something. But there's loads of resources out there now, and you're sport for choice. So I've drawn something that says confidence and age, and they've got question marks on them because I enjoy programming Scratch with my son as much as I did when I first started learning to program. So you could start off, you're a very young developer in that far bottom left-hand corner with Scratch Junior. Minecraft has some amazing tools for practicing programming, and it's a great game, of course, as well. Going along the bottom, there's these free magazines now, both by Magpie and Hackspace. There's a physical copy of them, but you can download the PDFs for free, and they're full of ideas of things to build. Going up the column, the Raspberry Pi Foundation provides loads of free resources, and other sites, including Real Python and Udemy, have much more structured courses. So there's lots of stuff online, often for free, you can use. Going out from that, when we would get released from our imprisoned COVID-19 restrictions, we'd hope to start going to code clubs again. There's Coding Dojo and Code Club, and there are loads of other ones as well. So there's your sport for choice here. And finally, maybe something like a user group. So I've picked the CamPub group, a very friendly group in Cambridge. And often if you go to their websites, they'll have a page somewhere on their site showing all the other resources online. So the real problem here is actually knowing where to look, where do you want to start with. If you're trying to learn something and you're not enjoying it, go and find another resource because there's lots to choose from. And of course, there's the books. So I grabbed my son's books this morning of how his coding's going. And these are great resources as well. Often, again, they're from Magpie, really good value. So you've got to be able to program on something. So having the course is one thing. There was a time when computers were so expensive, we only got slices of time from them. So batch computer on large mainframes. And laptops are still pretty expensive things. But you can program on some very, very affordable hardware now. So maybe coming back from the laptop, we've got the new Pi 400s, and they're in the order of about £60. And they start to go down from there to a Raspberry Pi Model 3 or a B at about £30. And then you can go down to the item that's just an angle. It's called the Pi Zeros. And they're about £10 for a fully functional computer with an operating system. The microbits and very recently the Pi Picos are microcontrollers. And you can also program on those, but they don't have an operating system. And they are tending to point towards more what we call physical computing. And from my experience with teaching children to code, the physical computing stuff is the stuff that people grabs people. So one example could be with those microbits, you can buy a sensor board for them, and this will sense temperature, pressure, and humidity. And with a little bit of code, you can have your own little weather station in the house.
Nice.
People love robotics. So again, I'm not affiliated with any of these brands, but the microbit has this platform which is called name's gone, damn, I'll try and find it out later. And you can basically plug it in, and with a bit more code you can get the robot to wander around on the floor and sense its walls and back up. And it's a great way to teach basically the turtle ideas of programming about moving and rotating. If you want, you can do something a bit more interesting and build your own chassis instead of buying them. They're called McQueens, but the little robot's called a McQueen. So you can, instead of buying the robot chassis, you can build something up. So again, my son, he wanted to build a robot, so we found all the Lego and built a robot with it. And eventually he got fed up with that because he wanted the bits back, and we found a broken toy, and we reassembled that into another robot. And that very much like the McQueen robot, we wander around on the floor, avoiding obstacles and backing up. And it's great fun. And you can also stick pens on them and get them to draw on paper for you and things like that. So it's a great way to learn programming. I want to leave with this quote, which I saw just this morning. Excuse me. So you could all read, I'm sure it's the reason why people give up is so fast, because they tend to look how far they still have to go instead of how far they've gotten. And because programming is such a large subject, it can be disheartening that way, because there's always something new to learn. But look back at what you've done, and often you get a big boost from that. Last thing, coming back to that first slide, we talked about the problem solving, and we've pointed a bit about courses and material available. the most common question we get is how do we get into programming? And I think the best answer to this is find a problem you care about. So it's very hard often to stay on these courses if you're not being assessed on them because it's sort of open-ended. So if you can find a problem you want to solve for yourself, that gives you a purpose to stick at learning something. Then you can think about the solution. So creative problem solving, get something working. And that's probably the most important next step. Get it working. Don't worry too much about making it perfect. It's much easier to enhance something after it's working. And then so get it working, then make it better. And then finally, just keep learning. Just keep repeating that activity and you'll get particularly good at programming and you'll get your mastery in software development. Right, and that's 15 minutes exactly. Perfect. Right, hand back to Steve.
Okay, well, thank you very much, Rich. That was very interesting. There was even a couple of tips in there for me. So we've actually got, maybe we could just have, before we carry on, maybe a couple of questions. And I don't know if anybody's got anything they'd like to ask Rich. We've got the Q&A open now, so has anybody's got anything they'd like to ask? No, it doesn't seem like anybody's got any questions at the moment. So we'll have time for questions at the end. But what we'll do now is we'll give you a brief introduction to all of the people who will be organising the hackathon today. So if everybody could turn their cameras on. And I will start. So I will introduce myself first. So hi, my name is Stephen Ingalls and I'm a software developer at the Sanger Institute. I've worked here for about 5.5 years and I'm a part of the team that builds software to track samples through our genome sequencing pipelines. And for the past year, I've been working as part of the project to track COVID samples on site. And this work has contributed to the COVID-19 Genomics UK consortium to sequence the SARS-CoV-2, the virus causing the current pandemic. My experience is mostly in developing web applications, which is why I am looking after the Reefer Raker project as part of this, which is a web-based application to track the location of samples in the reefers, which are big refrigerated units, which we have sitting in our car parks at the moment. And I will hand you over to Amy.
Hello, I'm Amy Day and I'm a bioinformatician at the European Bioinformatics Institute. I work on a large international project called the Human Cell Atlas, which is a project to build an atlas of all human cell types. And specifically, I'm helping to build software which kind of acts as a database to store experimental data from lots of different labs around the world. I first became interested in coding when I was about 22, 23. I was studying biochemistry at uni and lots of technologies were being developed at the time that generate a lot of data. And I was sort of learning about how there are huge amounts of data and we need sort of computationally literate people to analyze the data. So I decided to do a master's in computational biology to learn a bit more. And that's when I got into coding and I really enjoyed it. I love problem solving. And, you know, it gives you a chance to be creative every day. And I'd say that I never, ever took an interest in computers before then at all. Didn't really know anything about computers. So, you know, sometimes the interest develops later on and that's completely fine. And yeah, I look forward to helping you out with some of the activities this week. Who's next?
Thank you, Amy. It's Maria next.
Hi from me too. So it's actually great having a pass from me. Yeah, so my name is Maria. I am a PhD researcher with the European Bioinformatics Institute as well. I'm a biologist by background, and then I focus more on genetics. And for me, again, the interest in coding developed further because, you know, genomes require a lot of storage and a lot of size. And if you want to analyze a lot of genomes, if you get into coding, that helps a lot. And if it helps you also do your statistics and to progress your research in many ways. Here, I will be helping with the microbit workshop as well. And yeah, I'm very happy to see you all tomorrow and in the following days as well.
Thank you, Maria. Next, we have Sarmin.
Hi, everyone. My name is Sarmin. I work as a data scientist at the Sanger Institute. I only recently started working here after graduating with my undergraduate degree in biochemistry last summer. So I work in the Cancer, Aging and Somatic Mutation department in a group called Mutagraphs, which aims to analyze cancer genome sequences and identify patterns that could reveal new causes of cancer. Similar to Amy and Maria, I did my undergraduate in biochemistry, and I found that I really enjoyed bioinformatics and computational biology courses, and that's where my interest in coding started. So I hope you enjoy the Hackathon week, and I'm also helping out in the microbit workshop, and I look forward to seeing you there. And I will hand over to Beth, I think.
Beth, that's right, yeah.
Yes, hello, I'm Beth, and I'm a bioinformatics apprentice in the Cellular Informatics team at the Sanger Institute. I've been at Sanger for over 2 years now, and I actually started as a post A-level placement student. So prior to that, I was doing my A-levels, and I'd done biology, but I'd never done computer science. So I never coded before, which is kind of essential for bioinformatics. So on my placement, I learned to code. So I haven't really been coding for that long. And I then started my apprenticeship a year and a half ago. And it's a degree apprenticeship. So the way that works is I have one study day a week. And I study with Anglia Ruskin University, and we do some biology modules, some more computer sciencey modules, and then for the rest of the week I am working with my team. And the role of my team at work is mainly to kind of provide informatics support to scientists in the labs at the Institute. So we build software, we've got a laboratory information management system, and we analyze data. So it's quite a lots of different tasks we do. But yeah, I'm really enjoying my time at Sanger, and hopefully after the 4 years of my apprenticeship, I'll be able to continue my career in bioinformatics. And just as a fun fact about me, I'm a swimmer, and I've been swimming as part of a club for a long time now. So that's kind of my main hobby outside of work. But yeah, I'm really happy to be helping out with this, and I'm helping with the COVID informatics project. Yeah, looking forward to it. And I'm going to hand over to James.
Hello, I think this is which James are you handing to, Beth?
Right, James.
To you.
Yeah, I'm James Baker. I'm a postdoctoral researcher at the European Bioinformatics Institute, and I work on rare genetic disease variants. So each of us have about 100 to 200 variations that we don't even get from either of our parents. And I try and figure out which of those are benign and which of them might be causing some sort of disease. And I'll be helping Beth with the COVID variant interpretation workshop. So yeah, that's over to James.
Hi, I'm James. I also used to work on rare disease variant interpretation, although I don't anymore. I'm at EBI, and I manage a couple of databases on drug structures and indexing between other resources that are available for drugs and bioactive chemicals. I'm mostly going to be helping out with advising questions for the COVID variant interpretation stuff. I also have some experience with microbit and can field questions on those. My original background was in molecular biology, and actually similar to who's speaking before, Amy, I did a master's to learn programming and statistics and sort of get into bioinformatics because I just wanted to get out of the lab. But yeah, so there's lots of starting points for getting into this. And I am going to hand over to our next speaker, who is Amy again. Right, over to you.
Yeah, are we ready for me to introduce the activity? Yeah.
That's right, Amy. Yeah. So if everybody who isn't part of the microbit workshop could turn their cameras off.
Yeah. So I will be running the microbit workshops along with Maria. Do you want to wave or something, Maria? Sarmin and Kim, who couldn't make it today, but she'll be here later on in the week. And these workshops are aimed at less experienced coders or people who have not ever coded before. Children and adults are welcome. And the microbit, if you don't know what it is already, is a mini computer, a very small mini computer that you can write code to make it do things, interact with technology. It also has some sensors, so it can sense things like temperature. It can sense, it can measure lots of different things, and it can also output things like an alarm. You can use it to set an alarm. And yeah, lots of different things you can do with it. So we'll be running an activity based on that, and it will be focused on how you can use coding in a mini computer to help manage technology that you find in a laboratory. So first, it'll be something as simple as a fridge, and you'll find out more about that tomorrow. And then the next activity after that will be related to COVID sequencing that is happening at the Sanger Institute, and Kim will take you through that. Yeah, don't feel, if you've never coded before, that's completely fine. Feel free to take part. You don't need a microbit. You can use a microbit simulator in the web browser that we're using, so that's completely fine. But if you do have one, it would be really nice if you could use it too. And yeah, I hope you enjoy the week coming.
Thank you very much, Amy. So and now I think Beth and James are going to give you a bit of an introduction to their workshop.
Okay, so the COVID Informatics workshop is being held on Wednesday at 3 to 3:45. It's going to be myself and James Baker running it. And the purpose is really just to help people understand the COVID data and how you can use it to identify variants of concern. It's important to mention that there's going to be no programming in it, so it's really open to everyone. And in fact, there's going to be 2 sections. So the first is kind of going over some biology, just so you can understand like the fundamentals that you need to actually be able to understand the COVID data. And then we're going to cover what actually is a variant of concern, which is quite difficult to define. So we're just going to give you a few ideas about that. And then how you can use some of the resources linked in our GitHub. We're going to be running through how you can create a variant report, which is one of the predefined projects in our GitHub if you've seen it. And there's also a template for that, which we'll be using on our GitHub. So you can follow along with that if you'd like. And then finally, we'll have a Q&A. So that will be an opportunity for you to ask questions about anything covered in the workshop, and also just about the project in general. So please do come along to that. Looking forward to it.
Thank you, Beth. So finally, I'll give you a bit of information on the workshop that I will be running on Thursday. So I'll be running a workshop on Thursday at 2 p.m. for 1 hour. And this will be based on the Reefer Raker dynamic HTML project, which is a prototype for an application to track samples in our big refrigerated units called Reefers. And it will be based around actually one of the issues that's in the GitHub, which is I'm showing you here this now. So we will be live coding this. So if you want to come along and be prepared, then you can check it out first. It will be live coding and you can code along with me. We'll be doing a bit of HTML, CSS and JavaScript, nothing too advanced. So if you do want to code along with me, it'd be best to check out the repository and have a text editor or an integrated development environment and a browser ready. And don't worry if you get a bit behind, you get a bit lost, or you don't finish, or you just want to watch, as I will be making the notes and the example code available after on GitHub, so you can come back to it later if you want. So that's great. So that's you've been introduced to everybody. We've introduced to all the workshops, and now I'm just going to give you a few minutes on some housekeeping. So if you're working as part of this project and you haven't already signed up to the GitHub, please do, because there's lots of stuff on there that you can code along with. And what I've done is, you can see it here, we've got a welcome page, which I've set up, which gives you all sorts of information also about what's going on during the week. And just a few things to highlight. So the first major thing really is security. We want to make sure that you keep yourself secure and make sure that you keep your GitHub details secure and use an appropriate password. And there is actually some official GitHub security advice, and there's a link on this welcome page here, which you'd be advised to have a good look through. You can change your security settings by visiting your profile, but here are a couple of pieces of advice. It is recommended that you use something called two-factor authentication. If you don't really understand what that is, then you don't want to worry, but if you're a bit more advanced, it's a really good thing to add, because it adds an extra layer of security. And it's also recommended that for you to keep your emails private. You can change this by going to your profile, account settings, emails, and then check the box which says keep my emails private. This means that your email won't be shown to anybody else who's on GitHub or been sending stuff out to. And just one more thing that I'd like to say, just ask everybody if you could be nice. On this page, there's actually a link to the GitHub community guidelines, which we ask all people who code on things like this to have a good look through, and it will give you an idea of what is expected from you. But what we would say is please treat others as you would like to be treated yourself. And also, please remember that the organisers of the hackathon are trying their best and are working as hard as they can to make this a success. So please feel free to raise any concerns, but please do so respectfully, courteously, and with understanding, and we will make sure that we'll do our best to help. And the next big thing is make sure you have fun. And this is probably the most important piece of advice. We want you to enjoy yourselves this week and get stuck in. And we really do want you to have a go. So, you know, the GitHub is all up there. There's lots of stuff that you can try out. So join up to the GitHub, have a look around, see what's there. Don't worry if you've never tried it before. You know, just have a go. You don't need to wait for the workshops, and all of the instructions are there on all of the GitHub repositories to get you started. And if you've got any questions or problems, then please feel free to post something on the discussions board or via Engage. And the next thing, carry on. So although the Cambridge Festival is only from March the 26th to April 2nd, the projects will still be available for as long as possible. And I don't intend to remove people's access for that. So don't worry if you don't get a chance to finish something or start something during the week. Please just have a go and carry on. So just a bit more of an idea of the actual projects that are running. We've got 4 projects and you've already been introduced to them. So first we've got the BBC Microbit project, which is here. And that's to program a BBC Microbit and facilitate COVID sequencing in the lab. And it's open to all new coders of all ages with no experience necessary. We've also got the COVID project, which is here. And this is about COVID-19 open data analysis to identify the next variant of concern. Sounds quite complicated to me, but I'm sure once you've visited the workshop on Wednesday, you'll be able to get stuck in. And then we have the final 2 projects, which are the Reefer Raker, and this is like a prototype project which is built in HTML, CSS, and JavaScript. So if you've ever done any web programming, give it a bit of a go. And then finally, we have a really quite advanced project, which is a Reefer Raker using a JavaScript front-end framework called Vue Js. So it's actually the same as the other project, but it's a full project. So you probably only really want to start this one if you're a bit more advanced. And that's all the information I'm going to give you. But again, I just want to encourage you, the GitHub's here, sign up, get involved, start coding, start talking to us. Thank you very much. So if everybody could start their cameras again. And what I think we'll do is we've got some questions here that are unanswered. So what I could do is I'll just read them out. And then if people on the panel want to try and answer them. So, and this is a really good question from Margaret. Hi, I'm a programmer with years of experience, but interested in moving to this sector. Do you have any advice? And I think probably a good person to answer that would be Rich. Because really...
So I was looking at the question earlier. I was thinking obviously looking for job adverts, Margaret. That would be the good start. Getting to the practice of being interviewed and what people ask for. I can only speak for our own team. We don't expect people to come with a very strong biological background. So we've got people from games development, an ex-dancer, people who've come through from robotics companies before. So it's a real mixture of backgrounds for people. So for me, I think probably the thing we always look for is interest. So that we have a trailing or a leading question often say what caught your interest from the Sanger website, which is a huge website, and there's always stuff that new stuff been put up. So if people don't really show a lot of passion for the role, then they probably haven't looked at the website and probably haven't found something to read that they could talk about. So I think probably for me, the answer would be a passion for the role, the main thing.
Absolutely agree.
I looked to the bioinformaticians because it was about a bioinformatics thing.
Yes, and I would back that up as well. So you know, I had quite a few years of experience, but I didn't actually move into this sector kind of purposely. It was more because of the role, the stuff that was going on. So I don't think you need to get stuck in the fact that you need to know everything about what we do here to get involved, because that's what's happened when you start here. You know, and Rich is right. We just need people that have got a passion for programming. So the next question: I was a bioinformatician once, long ago, but have been out of the area due to disability for the past 10 years. What skills and tools that are now essential have I missed in the past 10 years? And I suppose really this is a question for the bioinformaticians in the room, and there's quite a lot of you here, so maybe one of you could answer it.
I'm quite happy to, just because I started learning bioinformatics almost exactly 10 years ago, so that's my career. Certainly when I started, there was a big leaning towards Perl, especially, well, at EBI where I work. And since then, everything has shifted massively towards Python. And the big change in I can see you're nodding along there, a big change in the last few years has been Docker containers and continuous integration. So EBI at the moment are migrating hugely to using Docker containers rather than virtual machines for a lot of our services. So getting some experience in managing those sort of clusters and understanding how they work is, I think, going to be essential in the next few years, because we'll have shifted our operations to that. So yeah, Python, pandas, continuous integration are my sort of top three.
Okay. I mean, I don't know if that maybe one of the other guys would like to, maybe Beth, because I mean, you know, you're a digital apprentice, so you're getting just getting involved into your bioinformatics career.
Yeah, well, I'm a bioinformatics apprentice, so I don't have too much experience. So I don't know obviously about everything, but I do know what James said about Perl and Python, because my team largely work in Perl. So I actually learnt to code in Python, but then I went to Perl, and whenever I tell people that I use Perl and they look at me and they're like, what? They're so confused. So I definitely think it's definitely moving towards Python nowadays. That's what I was thinking of saying anyway.
Okay. Anybody else got anything to add? Any of the bioinformaticians have got any nuggets of advice?
I think maybe one more thing is how to sort of interact with databases to request and retrieve and parse data. So like APIs and yeah, different sort of like file formats, how to work with them, that kind of thing.
So Beth, do you have good GitHub experience before joining?
No, none at all. I mean, I'd never coded, so I'd never used GitHub. But yeah, it took some getting used to, but yeah, it's a very important tool.
Yeah, it does seem the world has settled on that technology.
Yeah. But I will encourage anyone watching to try some of our GitHub projects, and that might give you an insight into the kind of things that go on here. So we have quite an interesting question here as well. Without a degree in coding, will I stand a chance to get into coding jobs or bioinformatics and compete with those who've got experience? because I'm very much inclined to shift towards that, but unable to do another master's degree due to personal circumstances.
Answer actually that a lot, I think, because I'm a person without a master's who went straight into a PhD program. So my first thing to say is actually depends the country that you're applying to. So I started coding in my undergrad, although I was a biologist, because I was doing my thesis computationally, and by myself I learned a lot of things. And then I worked as a research assistant. And after that, I had a lot of experience on this area, I guess. And I did not do a master's degree. I was looking straight for PhD options, also because financially it was easier for me. In the UK, I think it's quite easy. It's not easy, but you can go to a PhD program. So, and I know for a fact that EMBL, so EBI as well, does not have a quota on this. But for example, other countries like I think Switzerland or Germany require a master's degree necessarily before you transition. So for PhDs, I can definitely answer. I don't know about coding jobs for sure, but I guess it depends on the experience that you have to show. So if you don't necessarily have the experience or some kind of proof that you have worked in something, then it might be harder, or you have to start by maybe an apprenticeship or somehow find a transition. But I think the transition is possible if you at least try like a small internship or something, and you kind of prove yourself. At least I started with an internship, then it went to a job, and then to a PhD. So I think, yeah, it's possible without a master's for sure.
Yeah,
I'll just add briefly that we for our job adverts will always list a degree or experience. So we wouldn't discount someone just because they didn't have a degree.
No.
And that's certainly the case with the team. It's about 70% of people who've got degrees probably.
Yeah, and I'll back that up. And I was actually just going to say this exactly the same thing. So yeah, it used to be on our job adverts, it would say degree is required, but that's been removed. And I think what people would ask for is just some experience and some kind of passion for what you do. And I actually got my first programming job without a programming degree, and I did that by doing lots of coding. And that's kind of what you need to do. So we've got one question which says, my question is mainly about the hackathon, but there's no more, so I don't know what the actual question is. And somebody's asking, can I have the link for the GitHub project? And I put that in the chat for everybody. But if you need to find it, it's github.com/wgc-hackathon, and that's it. So we've got one more question here, another informatics question. So are there any courses, materials online that you found useful in your bioinformatics journey moving from wet lab to dry lab and would like to recommend? So that's another question there for the bioinformaticians.
Okay, I'm going to come here again to say, so for machine learning, if you're interested and you are a total beginner, I recommend the Coursera course from Andrew and G, because I think it's the best one I've done. And then if you, for single cell biology, probably Seurat and some R tools, which are very easy for people with not much coding experience. And then probably just some introduction to Python, but there are so many introductions to Python. Maybe somebody else has an idea about this. I'm not sure.
I agree with you about the course you recommended. I've heard of it as well, and a lot of people think it's really good. So.
Okay, cool. So there's actually a question in there for me from Aaron, and it was about the IDE for working along with my workshop. So that's really good that you're going to be at my workshop, so I better answer that. So you can do it with a text editor. So you could use Notepad or Notepad++, and we'll just be using a web browser. But if I would recommend an IDE, I would go for something called VS Code. And it's free to download. And if you download that, you should be able to work along with the workshop just fine. So we have a question that I don't even know how to. So my 11-year-old autistic son wants to be a white hat hacker. How should he start? I am the biochemist who didn't go down the informatics route. So for a start, I don't know what a white hat hacker is. So I don't know if anybody else can answer that question.
One of the good guys trying to find a vulnerability.
Ah, okay, right. So, and does anybody know how you would get to be a white hat hacker?
Well, it's not anything that I've done as a career, but sort of as a hobby to keep my hand in for making sure I don't design horribly insecure databases. I do like reading up on social engineering and exploits. So the book that I'm currently reading that might be worth a try and comes highly recommended on talks at things like DEF CON and the like is Social Engineering by Christopher Hadnagy, which is sort of the practices of getting your way into places that you shouldn't be and is as applicable on systems in real life. So that might be a point to start reading to see if it's something that he feels interested in. Especially as, you know, if you're neurodivergent, you might want to be taking a slightly different approach to convincing people, and that might be easier or harder in some ways. Yeah, it's definitely a job that requires certain social aptitudes. I'll send you the link to the book in the answer there.
Yeah, and I suppose sometimes the title that we call this a hackathon, but we are not hacking into people's private systems or anything like that. We are actually building stuff here, so we're not going to be doing anything naughty. So we actually have not such a question, but from Neil, who said, not a question, I found the interactive Python course on Coursera a really good intro to Python, and it's all making games which keeps you entertained. So thank you very much for that, Neil. And I don't think we have any more questions, unless anybody's got anything they want to ask. But what I will remind people of is you can contact us outside of this if you've got any questions. And also we've got the GitHub and we've got discussions there. So if you don't have any questions today and you have later, you can ask them later. So we do have one more question from, I am a bioinformatics undergraduate student. What skills, projects and experience should I have to be accepted in a master's degree? Any of the informaticians in there can help? No?
So yeah, that's the route that I took. What I tried to do was nab myself a third year project that had something related to, if not coding, then definitely command line work. So it was just drawing network graphs in Dot. This was before it was very easy to get hold of node drawing packages like, oh God. I'm sorry, I can't remember the package I used in my PhD, but I built one of those from scratch. If you can find a bioinformatics group at your university that would take on a third year student for a project, then that'll at least get you familiar with using Linux, doing some basic scripting, or doing some basic coding projects in Python, or just looking at databases and seeing how to use their APIs. That's what I did. I went and talked to bioinformaticians about third year projects.
Okay, thank you very much. And we did have a question there about the beginner session on Wednesday, but I think Amy's answered that. So it would be, I know that we had some questions about where people had come from today. I didn't see too many of those answers, but what I saw was that, you know, people have come from all over the country. And I did notice that some of these come from Ghana, so that's really good. I don't know if Alex or Emily can give me the results of the poll.
So we've got 13% of you have never coded before, and 41% have coded a little, 36% have some experience of coding, and 10% say they are experienced coders. So a nice mix with us today.
Good. That's really good to hear. So you know, all the beginners, don't worry. You know, I'm sure that the guys who do the microbit workshop will look after you. And for all the intermediate and advanced coders, GitHub is there. As I say it again, please get stuck in and get involved and write some code and post it and talk to us. And I think that's about as much as we've got to say. So thank you for everyone for coming along today. Thank you for everybody on the panel, and thank you for Rich giving a talk. And I really, really do hope that you all enjoy yourselves this week. Thank you very much.